All right, so we are going to talk about different asymptotes. And if you didn't watch my other videos, an asymptote is like when a little kid goes, "I'm not touching you," and gets super close, like super close, but doesn't actually touch. That's an asymptote. That's what a graph does. So to find a horizontal asymptote, and I use the term horizontal loosely, and you'll see why in a little bit. There's different mnemonic devices that can help you remember. So Bobo or Bobo or Bob Zero or Bob Zero, whatever you want to call it, means when you have a bigger degree, and degree is your highest exponent, on the bottom or in the denominator, automatically your horizontal asymptote is going to happen at y = 0. Eats DC means when your exponents are the same, so in the numerator and the denominator of a fraction they're the same, you're going to divide your coefficients. And then this is the one I don't like, Bodo, Bodo, whatever. When you have a bigger degree, I should have put that on there, degree on top, it's an other, meaning it could be a linear asymptote, a quadratic asymptote, whatever, and that's the one I don't like, especially because it's in like the horizontal part. So you can think of another mnemonic device. If you find another one, please let me know. And this is where you're going to really divide your polynomials. Then vertical asymptotes are going to happen when your denominator equals 0. This is because you cannot divide by 0. And so that's going to cause an asymptote because you would get an undefined fraction. So if you had whatever, blah, 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 divided by 0, this would give you undefined in the calculator, and that's why there's going to be an asymptote right there. And then this little note is going to come into play. You use zeros as placeholders. So if you have x squared minus 5, that's the same as saying x squared plus 0x minus 5. If you have x cubed plus 2x minus 1, that's the same as x cubed plus 0x squared plus 2x minus 1. And you're going to see that on the front side of this worksheet. I always write them in standard form, so that's when you have your biggest degree first and work your way down to your constant. And that's how you know which one you're missing. And you're going to need to use those zeros as placeholders because I did mess up doing this worksheet the other day because I didn't use my zeros as placeholders. Okay, so you cannot really see this whole worksheet, and I can't take credit for this worksheet. I don't know who made it. So I'm going to show you, you can see 6 of the 9 right now. I'm going to show you an example of each of those mnemonics we just talked about so you see them, and then I'll show you the rest of the worksheet and you can try it on your own, and then I'll come back with the answers. So the first one, A, is eats DC because you have x to the first and x to the first. They have the same degree. So to find your horizontal asymptote, you're going to take 1 divided by 1 because technically you can put a 1 in front of both of those x's. 1 divided by 1 is 1, so you are going to have a horizontal asymptote at y = 1. Your vertical asymptote happens when your denominator equals 0. So if you set x plus 5 equal to 0, what does x have to be to make that true? Or you can solve it like we know how to solve. Subtract 5 from both sides so this cancels. You're going to get x equals -5. Now the weird thing, and this still bothers me to this day, and you know it's been years upon years since I've been doing this, a horizontal asymptote has a y value. So my horizontal asymptote is going to be right here. This is y = 1. That's my asymptote. Then my vertical asymptote is at x equals, and that's going to be right here. Because x is always going to equal -5 no matter what my y value is, and y is always going to equal 1 no matter what my x value is. So that's an eats DC example. The next is a Bodo, where you're actually going to want to divide, and this one does not have a 0 as a placeholder because you have an x squared, you have an x, and you have a constant. So what I'm going to use is, you can do long division. I prefer the box, which is the area model. The thing to note, when you are dividing, it may not line up perfectly, and that's because you're going to be left with a remainder, and the remainder is how much you miss the constant by, whether that is 10 or -200, whatever. There could be a remainder, and actually D doesn't have a remainder, so I might change my mind and let's go to F because I want you to see an example where there is a remainder. So I'll be nice to you and show you that this is the other one of the other ones. I'm going to use a 2x2 box. Again, you can do long division. I just prefer, and let me reword this. Long division is better for finding your remainder. It is easier to find the remainder. However, I think it's easier to use the area model for the rest of it because I don't have to worry about changing my signs. I personally struggle with that so much that I prefer the area model. So I'm going to put my denominator along the side, and then I'm going to put my 2x squared in this top left box. What do I multiply x by to get 2x squared? Well, this is like a 1. So what do I multiply 1 by to get 2? 2. Or I can say 2 divided by 1 is 2. I have 1x, but I want 2, so I'm missing 1. So there's my top number. 2x times negative 2 is negative 4x. Now these are going to combine because they're like terms. I'm at negative 4, but I want to be at negative 5. So I have to subtract another 1 to get there. And again, that's because it's going to equal that negative 5 that I want. And then to get from 1x to negative 1x is just going to be negative 1. Negative 1 times negative 2 is a positive 2. Now here's where you run into the remainder. We wanted 5, but we got 2. So we would need to add 3 to get there. So my asymptote, and actually, we don't even have to worry about the remainder because it just wants the asymptote. So our horizontal asymptote is going to happen at y equals 2x minus 1. And this is technically a linear asymptote, but I'm okay as long as you know where it's coming from. And then your vertical asymptote is going to happen when x minus 2 equals 0. So we get a vertical asymptote at 2. So this would be something like this linear asymptote would look something like this-ish. And then that vertical would look something like this. And again, these aren't perfect. I am freehanding these. This is just to give you an example of what it looks like. All right, while I'm over here, look at the other ones we haven't done. And then you will have to figure out if it's Bodo eats DC or Babo, Bobo, whatever. I'm going to add the line right here. Because this can be written as 1 over negative x plus 3. Doing it this way might help you see. The concern and why some people don't write it this way is because that negative, you could also pop that negative out in front in general, which I'm not going to because I don't like that. I also don't really like it this way because it does concern me that you're going to lose a negative, and that's why they write it this way. But if you see this has a degree 1, this is technically, 1 is the same as saying 1x to the 0. Or anything, x to the 0. The degree up here is 0, the degree down here is 1. Because the bottom has the bigger degree, your horizontal asymptote is automatically going to happen at y equals 0. So that is on the x-axis. It's going to be hard to see. It's not going to have its own dotted line because it is the axis. And then your vertical asymptote, doesn't matter which one of these you solve. If we do 3 minus x equals to 0. Normally I would say move the 3 over, but you'd have to subtract, and then you would get negative x equals negative 3. You are not done right here. You still need to get rid of that negative 1 in front of the x to get x equals 3. If, because I am going to show you this anyway, yeah, it printed weird. So if you did 3 minus x equals 0, the shortcut is just add x to both sides, and you get 3 equals x. Yeah, you can do it this way. This is a very standard way, but this saves you a couple of steps. All right, so I'm going to show you all the problems again that you haven't done. If you like these mnemonic devices, do it. If you want to divide every time, go for it. And then I will come back with the answers here in a little bit. So pause the video, try these on your own. Don't forget about zeros as placeholders, especially with like this one, 0x and 0. Yeah, hint. So go ahead and try those and then come back and check your answers. All right, let's talk through a couple of these. So for B, the weird thing is when you have this x squared equals 2, to get rid of the squared, you square root both sides. When you physically write in the square root, because it doesn't tell us if it's positive or negative, it could be positive square root of 2 or it could be negative. So that's what this plus minus means, is it could be positive, it could be negative, we don't know. For C, we used it as a placeholder. I feel like most of you have got the vertical asymptote down. In this case, it's a linear asymptote. You're going to end up with x plus 5 because you have negative 5x, but you want 0x, so you have to add 5 to get there. And then you multiply and you have that remainder of negative 25 when it should be 0. Okay. Woohoo, sorry, dropped my thing. I was mixing up this problem with another. It did not work out well, so there is still a remainder. But again, the remainder portion doesn't matter. What matters is the whole part that goes on top of the box or on top of the division if you're using long division. You get 2x minus 7, and then your vertical asymptote is 1. There's a good chance I messed up on these. I tried really hard, but if you see a mistake, please believe in yourself. And if I see a mistake, I will come back and edit this video. E is eats DC for your horizontal, so you just divide 7 by 2. You can use 7/2 or 3.5. When it comes to graphing, it really depends on preference. We did F together, we did G together, H, bigger on bottom. Now the weird thing is this x to the 4th. It's just like squared, where to get rid of it, you take the root, but you're going to take the 4th root instead. Any even number that you take that's a root is going to have 2 answers, the positive version and the negative. What this means is 3 times 3 times 3 times 3 is 81, because 3 times 3 is 9, times 3 is 27, times another 3 is 81. The same goes for negatives. Negative 3 times negative 3 is a positive 9. Positive 9 times negative 3 is negative 27. But the negative 27 times the negative 3 will give you that positive 81 again. So if it were x cubed equals negative 27, that's only one answer. But we have an even degree or an even exponent, and we're even squaring, rooting, we are even rooting it. You're going to have 2 answers. And then the other one, I, your linear asymptote is at x minus 2, because you have x cubed, so you had to multiply by x. There is nothing else you're dividing by. Sorry, I was double checking. Yeah, because if you put more boxes down here with a 0 as a placeholder, it wouldn't change your answer. So you could, but you're just going to have zeros all along the bottom. And that's what I was thinking about in my head before I started explaining. And then you see that remainder is 5, because we didn't even get to the 5. When you're doing the vertical asymptote, x squared equals 0, this is the only time that's only going to give you one answer, because there's not a positive and a negative 0. It's just 0. So those are your asymptotes. That's how to help find them. Remember, remainder is a little different. I would look at one of the IM lessons if you want to talk about remainders. But they don't affect your asymptote. The only thing it does affect is do not be surprised if you don't get the number you're supposed to. Like we wanted 5, we got 2. We wanted 3, we got negative 7. So do not be surprised if that happens. Same if you're using long division. If you have a remainder and when you're finding asymptotes, that is okay. And that's all I've got for you.